Okay, so given that 3i is a zero of the function, what else must also be a zero if 3i is a zero? And then use synthetic to divide both out. So this is kind of a new problem. It's not something that I expect you to have to see a lot of, but it's an interesting one nonetheless. I have seen it on ACT before, for those of you who are juniors. If 3i is a zero, what else must be a zero? Why would negative 3i have to be a zero also? Because when you get the 3i, it's a square root, and so it comes with a plus or minus square root, always in the quadratic formula. So use synthetic to divide the 0, 3i, and negative 3i out. We've never done that before, so this will be the first time you've seen this. 1, 1, 3, 9, negative 54. Add down, multiply, add down. Can you add 1 and 3i? You just get 1 plus 3i. Multiply, which gives you 3i plus 9i squared. What is 9i squared? Anyone remember what I squared is? I squared is negative 1, so 9i squared would be negative 9. So 3 plus negative 9 is negative 6. Multiply again. 3i times 3i is 9i squared again, minus 18i. Would you agree the 9's cancel? Yes. Yes, I can. You're welcome. Is that far enough, or I could go a little more? Well, I can. What happens to the 9 and the negative 9? They cancel, and I'm just left with negative 18i. And negative 18i times 3i is negative 54i squared. And what is I squared? Negative 1, so I get 0, right? Should I have gotten 0? Yeah, it was nasty, but I should. So now I'm going to divide out the negative 3i in these coefficients. Now this is yucky, but is it really any different than anything else I've done? No. Move this out of my way. Hold on just a second. So I'm going to, as yucky as it may be, add down, multiply. What happens to the positive 3i and the negative 3i? When I get negative 3i, what happens to the 3i and the negative 3i? I get 18i, which is, that worked out nice, didn't it? X squared plus x minus 6. Factors of 6 that subtract to give me x. Well, and actually on this problem I could stop there, but x plus 3, x minus 2. Everyone agree with that? So it says find all solutions. Well, all solutions are 3i, negative 3i, negative 3, and positive 2. Yes. How far? So this was an interesting problem, gave us an imaginary 0. I just wanted to show you that it can in fact be done. It's yucky. We would rather not do it, but if we must, we can. This one could, because the -3 and the 2 are whole numbers, rational numbers. We could find them some other way. Now, if the other two were also imaginary, then we would have to do some process like this. Okay, today we're going to look at some applications of polynomials, and so I have this first one here. I didn't make this problem up, I promise. But someone very creative did. Population of geese have contracted a rare geese disease called cant quack melodicus. Dreadful in nature, it is wiping out the geese population rapidly in a small town of lumped quack. You have discovered that geese population can be modeled by this function, where t is the number of days from the first case of the disease. If no one can stop the spread of cant quack melodicus, when will the geese population be extinct? So what am I looking for? Zeros. I want to know when p of t equals 0. Everyone agree with that? So I want to know when this equals 0. Does this look like a problem that we will do by hand? No, it's got decimals in the problem. So pick up your calculator. And you have two options. You can put this in your y equals and put 0 in y2 and find when this equals 0. And I'll look the problem up. You can see it. Yeah. Victoria, have you already turned in the A part? So just tell me the way she makes it again. All right. Does everyone have this typed in? So you can go to the graph. And what do you notice? Yeah, there's not a big enough window to see anything. Now you may notice we're looking at days. So t is the number of days from the first case of the disease. Would there be any need to go farther left? No, because we're probably not going to do number of days being negative. So I'm going to go to my window. I'm going to change, first of all, my x-max, because I notice I don't see any zeros on 0 to 10. So I'm going to go 0 to, I don't know, 100. Try something big. And you can also change your y-max to be something bigger as well. Still nothing, right? So what do I do at this point? Change my window again. If you want to, you could go to your table and type in a couple of numbers and kind of see where looks like it. Hold on. 12? Are we crossing it? No. Oh, that's negative 12, sorry. Let's try 200. 400. They're still really big numbers. So 10,000. I finally get somewhere to cross at 10,000. Okay, I finally got a 0, right? Took me a long time. Agreed? Uh-oh. Did I type something in wrong? It's possible. Let me check my function. Oh, good. Okay. X cubed minus 0.06 x squared plus 3x plus 1200. You're right. Much easier. So what'd you say, 36? So 100 worked, is that right? Okay, cool. Alright, and I did put 0 in y2. Why would I put 0 in y2? Find the intersection, it's just a little faster. Second trace 5, enter 3 times. So I get 37.131. Now I want to show you another way to work this. It's a little more efficient. Any questions about how I got it that way? The other option is to go to apps, polysmalt, and use the polynomial root finder. What is a root? A 0, right? That's what I want. The degree of the function was, what was it? 3? Was it x cubed? Yep. So 3, and then I'm going to go to next. I'm going to type in the coefficients. Then I'm going to go to graph, which is the solve button. Now, it gives me 3 answers, and I want you to be very careful about writing those other 2 down. Anytime you see a plus or a minus after an answer in polysmalt, what do you imagine is about to be after that plus or minus? An I, right? Do I care about imaginary answers on geese? No. So the only correct answer is the 37.131, which is the bottom one. This is a little more efficient as long as you're careful about picking out those imaginary answers. Any questions about either one of those options? All right, let's look at this next one. A company has found that the daily profit in dollars for producing and selling a product is given by that function, where X is the number of hundreds of units produced. Determine the level of production that gives a break even. If this is profit, what will I be looking for if I'm looking for break even? When a profit equals 0, so what am I going to do? Yet again, put this in y1, 0 in y2, and find the intersection, or this in polysmalt and find the zeros. So do that for me. would type this in y equals even if you are going to use polysmalt, because of the next 3 questions on it. You can see having it in your y equals will make your life a little easier. I'll try to type mine in correctly this time. What did we get for our break even? 104 and negative 1.5. Which one of those doesn't mean anything to us? The negative 1.5, why does that not mean anything to us? What does X stand for? Units produced. Are we going to produce negative 1.5 units? Probably not. So the level of production that will give a break even will be 400 units. Why 400? Good. X represents the number in hundreds. So if it's 4, then there's 400. And 100 hundreds, how many is 100 hundreds? Good, 100,000. So we have 2 places where we break even. It's at 400 units and 100,000 units. How much profit could they expect to see if they produce 5,000 units? How will we do that? Say it again. Which one is the number of units produced? What variable stands for units produced? X, right? In fact, P is the profit, right? So we're going to put something in for X. Do we want to put 5,000 in for X? What do we want to put in for X? 50. Why 50? Hundreds of units, right? So if I have 5,000 units, I could do 5,000 divided by 100 and find out that that's 50, which is what they did in their head. 50 100ths. If you already have this in your y equals, just go to your table and type 50. And you get $23,690. And what I did is I typed P of 50 to get that. How many units do they need to produce to make $10,000? How can I do that? How will I work that problem? What is 10,000? Where does it go? P, right? So 10,000 equals negative 0.2x cubed plus 20.5 x squared minus 48.8x minus 120. What are my options for solving this equation? You have 2 and they're great. Both great. Good. Graph I already have this in Y1, put 10,000 in Y2 and find the intersection, right? What if I want to use polysmoked? Could I? I would have to subtract the 10,000 over, wouldn't I? To get 0 on one side. But I could do that as well. Either one works. So if you subtract the 10,000 over, you can use polysmoked. If not, you type 10,000 in Y2 and find the intersections. If you are using the calculator, would you agree your Y max needs to be bigger than 10,000 if you're using the graph? Y max needs to be bigger than 10,000. There are two intersections. Everyone agree with that? Two ways that we could produce 10,000 units. Now, I don't know about the polysmoke. You may even get 3. But for what we're looking at, 2 is all we're going to get. They may get a negative answer in polysmoke. Second trace, 5, enter, enter, enter. I get 94.208. Will someone write that down for me? And 27.688. Okay, so I got X to be 26.688. And I got X to be, what was the other one? If these are in hundreds, how many units? Maybe 26,688 units. And 94,208 units. How many units would you advise them to produce in order to receive a maximum profit? And how much is that daily profit? Well, would you agree it's up here somewhere? Way up there somewhere? So let's go move our window. 11,000 is no longer big enough. I'm going to try 20,000. I don't know if that'll work or not. Big enough? Not yet. 50,000. I need to see that top point. And I'm going to go to, how do I find top points? Maximum. Second trace, number 4. I go put my cursor on the maximum. And then I move to the left of it and push enter. And then I go back to the maximum and then go to the right of it and push enter. And push enter again. And the maximum is at 67.121, 28,482. It asks 2 questions. How many units do I need to produce? Would you agree about 67,121 or 122? Everyone see how I got that? So I need to produce. Why did I use the X for that? Why did I use the X to get how many units to produce? We sleeping? Why X to give me number of units? Because that's what X is. It is very important in a word problem to know what is X and what is Y. So X is the number of units I need to produce, And why did I make it 67,000 instead of 67.122? Because it's in hundreds, right? So 67, isn't it? Or that, what was it in? Hundreds of units. So 6,700, which would be 67,000, right? 67 hundreds. No, I put too many zeros in there. Y'all were gonna let me do that, weren't you? Right. 6,700, and I think I did that back here too. Let's go fix both of those. Did it above too? I'm off my game today, huh? We did it right on the first one, the 50. Is it decimal point, right? And yeah, because this was 20. What's that right there? How do you get that, by the way? How do you get these numbers if it's in hundreds? Multiply by 100. It's times 100. I did times 1,000. Sorry about that. And then the maximum profit is... What was the maximum profit in my calculator? I've already... 28,182. 482. And how many cents? 59 cents. Okay, any questions about that one? Are we confused about the hundreds? Since I messed it up. We okay? Alright, this is your homework. Page 452, numbers 44 through 46. There's 3 problems there. And then 464, 32, 34, 39, 40, and 42. So you got under 10 problems. Of course, there are going to be some A, B's, and C's in there. So, any questions? This is your homework for tonight. And then there is a quiz tomorrow. Did we really learn any new math skills today? No, we just put them with some word problems and combined some things together. Word problems are typically calculator problems, so